So, hi everyone, welcome back if you were here earlier, and welcome if you are here the first time. My name is Charlie Berger. I am the Senior Director of Product Management for Machine Learning at Oracle. I've been at Oracle for a long time, ever since Oracle acquired a company called Thinking Machines, where we had separate algorithms, but what we've done is to put those algorithms inside the database on this general theme of move the algorithms, not the data. And I'll go into that in a little bit of detail, but not too much because I covered this already for a lot of you. Safe harbor statement, in case I'm talking about any futures. I always like to open up with Larry because people kind of pay attention, and he's talking about my product, these machine learning functions that are now in this ever more capable converged database. So multi-tenant, in-memory, sharding, JSON, and machine learning, also spatial and graph, and so on. So we're part of that. And when you do that, it opens up a lot of opportunities. It just makes it easier to, at the end, discover new insights and make predictions to put that data to work. It also opens up a whole world of opportunities that the second half of this presentation, I'll talk about sort of a specific way to think about how to evolve your skill set to pick up more and more machine learning. I think it's a very natural thing, and frankly, what I'm most excited about is not a theory; it's an observation. The observation is that it's been easier to convert and grow and sort of what we'd say coach up an Oracle data professional to become an Oracle data scientist than it is, because they already know the data, they know SQL, they know if they don't know the difference between a mean and a median, I say, well, maybe this isn't, maybe this is not your thing. But if you're analytically curious and you know things like that, which is to me probably most of the planet in the world of SQL, that is, and Oracle, they know at least some math, then you are very much a candidate to become a data scientist as well. And that has been an easier journey. It's probably been 10 to 1 or 20 to 1 than trying to take a person who is totally into open source, Python, TensorFlow, R, you name it, and have them appreciate the database as a place to do their machine learning. They don't understand what the database is good at. They don't understand the privileges and the access and the backup and the different data types and the triggers and scheduling and all the things that the database does well. So what's been interesting is this journey to go from the left, as we automate more things, to have people move further over here to become more of a data engineer, generating the right variables to go into a model, running a model, and as we do things like auto ML, it's even more automated. It's always been automated, but it gets even more automated, and then ultimately to build some sort of application. If you don't know what machine learning is, if you do, my apologies, I don't mean to talk down to anybody here, but a lot of people, it's something a little bit new, a little bit curious. I think it's always been way over complicated. I come from many years in a statistical kind of background, and there you kind of had to know which statistical technique do you use, and is it a normal distribution or not, and you had to go to this kind of cookbook of statistical recipes. And even the guys that had PhDs in that stuff, I'd go to them and say, well, I'm not really sure, do I use this or do I use that? And they'd say, I'm not sure either, let me go to the textbook and look it all up. And in machine learning, it's a lot easier. It's machine learning. The idea is that the humans sort of have a well-defined business problem, pull together the right data, and kind of know which category of algorithms they should sort of point at their data. And if you're doing what we call supervised learning, where you know what the target field is, like Jasmine Fleury earlier this week did a thing on predicting the number of skiers in a ski area based on recent avalanche risk, recent number of cars in the parking lot, recent temperatures, day of the week, all these kind of things. So if you know exactly what you're trying to predict, then and you have labeled data, that would be what we call supervised learning. If you don't, and you're just trying to look at the data and find unknown patterns and relationships, or find rare events like fraud or market basket kind of relationships, like people who buy this also buy that. So if you're trying to do very important things, but you're not really trying to oversteer the algorithms, you're just trying to say, you tell me, then that would be unsupervised learning. And of course, inside the database, we have many of algorithms that can be used for these things, but also I think that machine learning is oftentimes oversold, that it cures cancer, it provides world peace. I mean, it stops global warming, and it's just a bunch of math. It's applied math. People will claim it has been used in all these different areas, and it probably has. I got this off the internet. The ones I've underlined are the ones where I've had some fingerprints on those projects, worked with some customers, did the work myself, and I can kind of attest that, yeah, makes sense. Some of the other ones that I did not underline, it doesn't mean that machine learning algorithms could not be used there. I think it's just that different techniques like social graph analysis, that's not really what I'm thinking as a, now profile segmentation, yeah, I probably should have underlined that, but the graph analysis is a slightly different family of techniques that would come in the Oracle spatial and graph option. We'll probably do more, you could put those two things together. That's probably one I could have, clicked on, but clickstream analysis, clinical trials, that's usually using, SAS for, or R for well-defined things. So I've tried to highlight some ones that at least I think make, I've observed. Now, one of the other things why I'm so excited about you guys being able to pick up more and more machine learning is this situation, which is what's going on today. Most machine learning projects don't go to production. And Fern Halper did a really great study here. She asked, how long does it take to have a model go to production? And I always kind of heard people say this, and I never really knew what they were talking about because it made no sense to me. But 3 months, 6 months, 9 months. Why? Well, because the model is built in R or Python or SAS or SPSS. You took the data out of the database, you did all these data transformations for domain reasons, like what's your amount of bonus compared to your peers. You did a little transformation either in the database or outside of the database. Oftentimes you're taking the values of the variables and for the purposes of the algorithms, you are normalizing them between 0 and 1, right? And you have to reverse engineers on the way back out. So for all those reasons, when you try to productionize that kind of logic that's occurring outside the database, and you want to run that into the database, you have to recode all that logic into SQL or PL/SQL oftentimes, and that's why it's a mess, right? And so that's Fern's observation or survey. This is my opinion. They must be using products like that are all outside the database, because I can't imagine it taking that long with Oracle. Most of my customer references, and I can show you some of this, build a model, score a model, bang, you're done. And if you want to, there's a really nice hands-on lab we're going to be doing, I think in November. We've got a few of these things going on that says I'm going to build a model on the autonomous database. You can get a free version of the autonomous database, and I'm going to deploy that on the transactional autonomous database. I just basically export the model and upload it and run it inside the other database. So you can do this quite easily. That's what we designed Oracle Machine Learning to be, is just an extension of the database's capabilities to also, which undergird many applications, and now they also can undergird analytical applications or predictive applications. This is that study that said 87% of data science projects fail to go into production for this logic that's described right here. You're asking an engineer to rewrite a data science model, and that just usually doesn't, so there's a lot of discussion around this. But this is like the dirty little secret in data science. Most data science projects never make it into production, unless you're a Google or a Facebook or something like that really has the teams, has the effort, has the work to do it. But if you're just at a bank or an insurance company, I mean, like Certegy, I mentioned the other one, they're going to talk later on today, actually, but it'll be recorded, don't worry. The guy there has 900 input variables, and he's been using Python. And I said, how do you deploy that? And he said, well, I set up all these VMs, and I schlep the data over to the Python VMs, and I score it there. And, don't worry, it kind of works, But now he is saying, wow, I can do all this just as a function inside the database, as a SQL script or whatever, much better. And that's really what we try to design. That's what we hope will be of use to you. And if I haven't said it before, this stuff's all free as well as of December 5th. So I'm not going to cover in as much detail as I covered the last time. The product is called Oracle Machine Learning. It is part of the database, and it extends the database with these analytical functions. The way that we do that is to move techniques like the one on the right, which is a naive Bayes technique. It's just counting, and the database counts things really well. So we move that inside the database, and we have the database do the counting. So it's just a complex query. And at the end of that, the technique here that's getting a conditional probability, what's the likelihood someone's going to buy a Tesla car based on their age, their income, you know, what was their previous car they owned? Well, I can do a conditional probability model inside the database rather easily, and that's what we do. Over the year, that was our first algorithm that we added, that and association rules, for complete in-database processing. We've since added many more techniques, clustering, classification. We've since exposed those techniques to other languages and integrated them with other languages, so you can call these same functions from R and later on this calendar year Python on the autonomous database. And I think what we've created is something that could start to be called, and I cringe because I come back from the second AI winter back in the 80s. I lived through it. I do not like to oversell anything as AI. I hesitate to use the term AI. I don't think I even did. Yeah, I didn't. Oh, I did have AI database down there. But everyone else is calling things AI, and if you're not somehow AI, you're like, you know, you're not cool. So take the AI with a grain of salt, but the idea is I could take every attribute in the database and I could use that to predict the value of another attribute, right? Take 500 attributes and predict the 501st attribute, right? And you get a pretty good prediction and a probability and a reason why. I could iterate through all those 500 variables for like 200 million records, and predict everything else. I could predict everything else in 24 hours on a properly sized Exadata box, like an autonomous database. I could do that in 24 hours 4 times. 4 times. And so if you have a properly sized database and you have a bunch of scripts and you think about what you want to do, you've transformed your data into sort of a thinking database with predictions about, you know, what's my savings account balance? What's my predicted savings account balance? What's the number of, I always joke, what's my marital status? What's my predicted marital status? Anything, you know, am I going to default on a loan? I could almost have this crystal ball that's always making intelligent predictions. I covered this last time. Net, we have a lot of algorithms. They're not your father's machine learning algorithms. They are in database implementations. They can mine structured data, unstructured data, transactional data, and they run really lightning fast. So what we have for product offerings, depending on if you're on the cloud, would be the notebooks. If you're on premise, that'd be the more thicker kind of clients. But we've covered some of this before, so I'm going to skip over this. Under the hood, I covered this before. It's just some SQL, create, you know, DBMS data mining, create model, target field, type of function, classification, input data set, unique identifier, and so on. And once I built the model, I can apply the model using dual, using a batch, you know, however I want to do that. It's just simple syntax. If I want to do an attribute importance, it's the same thing, except it's attribute importance. And then I get 0.2161, 0.14, and so on. If I say, no, Charlie, I don't really speak SQL, I'm more of a R guy, well, we wrap and expose and integrate our algorithms over to the language of R. So you can speak your native tongue of R, drive the same in-database algorithms that we just showed on the previous slide over here. So instead of doing it that syntax, you'd use this syntax, and you get your same 0.2161, 0.14, and so on. You're just, you know, you're not making all of R run faster and better. You're making R users familiar and comfortable with using our in-database algorithms. And if they still want to use R to do whatever they want, they can do that. And we even have embedded R callouts that are sort of optimized in certain ways. But it allows to sort of tears down that barrier between those two worlds. Similarly, if you speak Python, you can do the same sort of thing. Speak your Python language, get the same language, same results, and so on. So now up a level, up to the graphical user interfaces. This is part of SQL Developer. This is what, frankly, most people use most of the time. Probably 90% of the users are using this because it's just so easy to use. And while I'm just kind of talking for a minute, I'm going to play this little embedded video to save myself a little bit of time here. This is part of SQL Developer. You access it by clicking on Data Miner, and you launch it. It'll set up these little projects and then workflows within the projects. Under the hood, it's running that kind of code, but it's easier to use the GUI. I drag and drop things like the data node. I'm looking at the columns. I'm looking at the SQL. It's all inside the database. I can do an attribute importance, or first thing you might want to do is visually understand your data. So we've run statistics, min, max, standard deviation. They're all available here. We can show, nice little thumbnails, and then click on them and see more information with a grouping variable. There's the statistical summaries. I can do something here where I say, show me the key variables for a target field. We also, I didn't show it last time. I had run it last time with unsupervised learning, which said, I don't have a target field, just in general. Maybe I have a bunch of data coming off a big data appliance, show me the key variables. Here, I'm going to run 4 different models, all sort of shotgunning at the same point. This is not auto ML that I'll show later on, but auto ML leverages those algorithms and the automation that we do here, like system determined and solver. You know, these are all system determined auto ML things already, but we add even more. So we've done a number of different models. We get to compare them in lift charts and various different confusion matrices and so on. After we're done, we can apply the models. Well, we'll visualize it to say a decision tree here. Very interactive and so on. So I've covered a lot of this before. I'm going to skip out of this guy here and move on to the, I guess get out of this guy, move on to the next one. R. I didn't really show enough of R last time, so I'm going to show what we do for R. I think on the next slide I have a little bit of a embedded demo here. I could go do this live, but it's quicker and cleaner just kind of watching this thing go by. So I do the OR. First, I load these packages. What do the packages do? They do the sort of the handshake between the world of R and the world of the database. So there's a data connectivity, the OCI connectivity. There's the or OCDB, you know, the database connectivity. There's the here's when I do summary statistics, summary ODMR cars, or the box plot. Those all require a certain amount of statistical computation. The database knows how to do all these statistical computations. So I say what I want to do in the language of R, and like that box plot I just created, that is calculating the median, the 25 percentiles, the 3 sigma values, all on, say, billions of records inside the database, and then throwing those partial results back up to the graphing widget of R. So that R is not doing all that analysis by itself. We're doing the analysis in database and using R as a graphing widget. When we come to the notebooks, we do you have a more modern, you know, this is what a lot of people are going to, a Zeppelin notebook style for doing things. It's a collaborative user interface, and I'll cover that a little bit more, I think. I was talking a little bit about some of the futures. I covered this before, so I'm not going to go into this a whole lot other than in the notebooks. We'll also add the support for R, for Python, and then later on R. The Python should be anytime this calendar year. It's been way overdue. There's been a couple of technical gotchas we run into right in the 1 yard line that set us back a little bit, but that's coming very soon. If you have any questions, I covered this in the previous one, so I'm just kind of skipping over this a little bit. Some of the new techniques, XGBoost, MSET is a process monitoring anomaly detection technique. Again, if there's any questions, raise your hand because I did cover this literally about half an hour ago. Yeah, go ahead.
Charlie, there is one. Let me just read it you. So machine learning models are usually very high CPU consuming. Database CPUs are, on the other hand, not the best choice for this kind of processing, in brackets GPU. Do you have any comments?
Yeah, I do. Let me go over here and see if I can point you to something that we just recently put out. It's on the, or I'm Googling Oracle machine learning blog. So I've got a few different posts out here. Mark Hornick recently posted something just a week or two ago that has a lot of performance benchmarks, and you can, you know, prove it to yourself, make sure you feel comfortable with it. But before I click on this, the main premise is I don't move the data out. So I'm not taking any time to schlep the data, import the data out, export the data, import the predictions, export the predictions. I'm not doing any of that stuff. So disregarding all of that, if I just press go, if you have a properly sized database, we're not doing a single threaded memory constrained kind of thing, which is why people go to NVIDIA boxes and such. My brother, you know, just left NVIDIA. He retired actually, but he was in NVIDIA for several years, so I'm familiar with NVIDIA and such. NVIDIA is mostly really good, we think, for doing image kind of analysis, things of that sort. Most of what we're doing currently, we can score NVIDIA model, we can score Onyx models, but most of what we're doing is building a model inside the database. So, you know, this is a little bit more about such. Here's the Oracle database, and if you click on these guys, you can see, you know, how long it takes to, maybe make this say it's kind of a little bit small here. how long it takes in 400 million records, 800 million records, and the elapsed time in minutes in log scale. So take a look at this. There's a lot of data there, but the net is it's like running a query inside the database. So it's totally parallelized. If you have 512 degrees of parallelism, we were building, we had, what was it, 900 variables, 640 million records, 512 degrees of parallelism in the Exadata box, and we were building generalized linear models and clustering algorithms and such in anywhere between, I think, 90 seconds to 5 minutes. You know, it is because it's like running a complex query on the database. The database is designed to be fast and to break the task down into parts and parallelize it. That's our secret sauce. That's what we've done at Oracle, is to teach the database how to do. I'm going to take this thing here and put this in the chat window here so you can find that thing. And if you get there, there's a lot of other good things there too. This is supposed to go to all panelists and all attendees. So there you go. So yeah, I mean, don't trust me. Try it out yourself. I can show you all demo after demo after demo, but I build models on the wine data set with 130,000 records, and I'm doing text mining on them on the Exadata box, on the autonomous thing, and I do that in I don't know, 5 or 10 minutes, something like that. And I'm wondering why it takes so long, but I think it's because of the text mining that's part of that. Any other questions? No? Okay.
Sasha, so just a second. Sasha, did you get your answer? Or response, sorry. Okay. Okay, just go on.
Okay. So we have some new techniques. We also covered AutoML in the previous one, so I'm not going to go into all the details of this again, except it's a more analytical methodology that assembles many different parts together to enable non-expert users just kind of click and use machine learning. And the presentation is about the changing role of the DBA or the data scientist, I mean, the changing role of the data professional to evolve to add machine learning skills to their repertoire. And this is yet another thing that we're doing. This is probably the next frontier, the next future kind of thing that I think you will hopefully all like. It's called AutoML user interface because it's using the AutoML under the hood, but then we provide a cloud-based thin client user interface here where I just click on AutoML, I pick, I want to do something, I want to target the best customers, I pick a data source, supplemental demographics, pick a target field like affinity card users. It'll do a certain amount of data profiling just by click. I mean, I'm up to like, what, 3 or 4 clicks right now. It'll do an attribute importance. It'll shotgun a number of different models here, but in an intelligent AutoML way. So it won't brute force it. It'll do it more intelligently. It'll give me all the summaries of all the different models that it's run, and all running our in-database models. We're not doing like OCI data science, you know, Python models or data robot or TensorFlow per se. We're doing what we support inside the database. At the end, when you get a very good model, you can create a notebook and you can deploy it. And I covered some of the stuff before, so I'm going to skip over all this. And so, but wait, there's more, because once you, and I'll cover how to do the data science thing in a minute, how to sort of evolve, but if you imagine that you've done all these predictions, then you can now use all the rest of what you probably know how to use very well already, like Apex or any of the Oracle kind of products, to now make really cool reports and dashboards. And I can probably call this thing up live on another window, but let me just keep it this way for the moment. I've done all these predictions of who's likely to leave or stay using some employee attrition data. I know that the OCI, the Oracle Analytics Cloud guys have been showing an employee attrition demo for a few years now. At least, you know, that's what Philippe and company tells me. We've worked with them. They can now call our models. So this model and these predictions all were done inside the database this time. So we didn't move the data. We didn't use their sort of pull the data out and use Python to do it. We did it all with the OML algorithms inside the database. And now we're merely just sort of pointing to those results. So now I can use their faceted search to just pick people that are more likely, you know, probabilistically to do something. I can predict, you know, for research and development, and all these graphs and tables will update. I can also see their key variables that are driving something, overtime, job level. And this is my favorite part of Apex. Apex is a wonderful product and it's free. I can say the probability of attrition, the years at the company, and when I hover over here, I should have gotten this in the screenshot. When I hover over this, it tells me more information that's part of the label of that. And I can say just the people who have been with the company for a long period of time and are likely to leave, who are they? I want to know about them. I can actually do what if analysis and things like that as well. But the idea of making more intelligent reports and analytical dashboards using OML under the hood, I think is exciting. But there's more you can do too, which is now I could take those results, go to OAC, Oracle Analytics Cloud, and the new thing they've done is I can register a model, and I showed this before, so I'm going quickly. I can take a model, I can register the model, apply the model, leave the results inside the database, and then come back in here and look at those employees or whatever they're most likely to do something. My favorite one we just did is this wine. I'll skip over that. And I probably already talked about this before, so I'm just going to skip over this and go to the second half of the presentation. So the second half of the presentation is talking to the idea that there's this natural evolution, I think, that you're seeing in the industry. And there was a pitch that Oracle was doing, like Larry Ellison and company, they would say the changing role of the DBA, and it was all the impact of the autonomous database. That was too narrow of a definition for me. I started to use that earlier on, and I've kind of evolved it because it's not just a DBA, it's not just a database developer. It's really all of the Oracle data professionals that basically know their data, know their company's business, and can spell SQL. And because we've moved the algorithms to the data management platform, to the database, it opens up all these opportunities. And I've seen so many customers do this evolution. So what is the evolution? The evolution is that you're probably already doing a lot of this work today. You're probably already doing data extraction, data wrangling, deriving new variables that we data scientist type guys would call feature engineering. Feature engineering sounds cooler than deriving a new attribute. That's what we call it. We call it feature engineering. And then there's this little part where the machine learning magic happens, and that's always made too, mysterious. It's like, oh, do you have a PhD? Oh, you don't? Too bad, because I do. And I don't actually. I got 2 masters, but machine learning is meant to be approachable by more people than PhD guys. There, especially as we go more into auto ML, you just need to know what you're trying to do. The algorithms will take over and do a lot of stuff for you, and you can control them. You can see what they did. You can feel comfortable with it. You'll have a test, a holdout sample, things like that. But then you're gonna drive it. You're gonna let it do the work that you want it to do, and then you can turn those insights and predictions into applications and automate things. So aside from this little machine learning stuff right here, I contend that a lot of you are already doing things like this, and it's not so hard to do. And I'm using this methodology that's called the CRISP DM. It's the cross industry something or other data mining method. I forget what it was. Had some fingerprints on the design of this many years ago, and I thought it was just too simplistic. But because of its simplicity, it's held up over the years. And each one of these areas are the key things that you have to do. I've been writing a blog series on this. You can read books on it. They're a little bit lengthier, but each one of these things are actually associated with many sub-steps, and that's where people get kind of overwhelmed. So when you assemble the right data, there's what is the right data? There's data visualization. There's various different statistics. When you do the data preparation, you want to do missing value treatment, binning, normalizations. What if you have unstructured data? All these kind of things, as you go into the details, sort of gets a little bit more complicated. If you're using Python or R, you're using a little bit more primitive form. And so, yeah, it is a little bit more complicated. At Oracle, we've really worked towards trying to simplify and automate wherever possible. So I've dimmed all those things that we think we've got reasonable defaults for, or if you just, click, it'll do it for you. You can override, you can do whatever you want manually, but you don't have to worry about these things if you don't want to. So what we're trying to do is make machine learning simple. If you're using the drag and drop GUI called Oracle Data Miner, then these nodes are associated with many of those steps. Okay, deployment would be score a model. Model building, we're going to have an automated train and test stratified sampling going on in that little node. Data preparation, notice I don't even need to have the data preparation go into here because I do a lot of it automatically in the main flows. So there are specific nodes that do specific things, but also if you look at it, we try to simplify that. If you're using the notebooks that come with the autonomous database, there are example notebooks. They're very simple. Why? Because I created them. I've had some help since to kind of, tweak them a little bit here and there, but they're very simple. Okay, I can say that firsthand. But they're also just the basics. It's just getting through everything, and they solve 90% of the use case you're going to run into, I think. And so you can take those as templates. So what I'm going to take in the next 20 minutes, I guess, is take you on a quick journey of how I think you can evolve very naturally, very straightforwardly. And a lot of people know I've been trying to learn how to play the guitar. I also do already know how to ski, so I can. If you can relate it to any kind of skill or sport you're trying to learn, imagine learning how to ski. Like, first thing you want to learn is how to stop, then you want to learn how to turn, and so on. In playing the guitar, you learn how to, I don't know, hold the guitar. Then you learn how to make a C chord and then a G chord, and you learn how to do certain things. And by the time I leave this planet, maybe I'll learn how to play better than I do now. But it's sort of a journey, and each part of that journey requires you to do a little bit of reading, a little bit of YouTubing, a little bit of practicing. And if you do that in this sort of structured form, I think you'll kind of work your way down this path. I don't think you want to just go straight to like click and go. I think you want to think about things, and I'll tell you why. So the very first thing we're going to do is business understanding. And this is frankly where most people mess up the most. I can give you countless examples and stories, but I'm going to skip all that and just say, look at all these great business understanding statements. They look great, right? Especially the last one. Can you, I've got all this data, can you mine it and find some useful insights? That's the worst one of them all. I don't know how many times I've seen that, like, hey, Charlie, does your tool really work? And could we give you some of our data and you run it on there and see if it works? It works, okay? It's like asking, does my calculator add up 3 numbers correctly? Oracle machine learning works. The question is, do you have a properly defined business problem? Like in the thing I mentioned earlier, Jasmine Fleury yesterday did, or 2 days ago, did a really nice talk about predicting the number of skiers at a ski area. And people were thinking, oh, that's a forecast, right? Well, it wasn't a forecast over a long period of time. It was a prediction. How many people will be here tomorrow? How many people will be the next day? That kind of thing. It was very, very explicit prediction, and it was very well defined, very well done analysis. And so what seems to be very nicely defined business problem statements are actually not so good. And the way to improve them is to use old Albert Einstein's adage that, if he had an hour to solve a problem, he'd spend 55 minutes thinking about the problem statement, and then the last 5 minutes thinking about a solution. So imagine Albert's asked to save the planet. Albert would probably say, well, what do you mean by saving the planet? Do you mean all the men, women, and children, or just the women and children, or just the men? What about the animals? Do you want to save the animals? What about the trees? What about the fish? Do I have to save the fish? How long do I need to save them for? Because if I just needed to save them for 5 minutes while an asteroid shot on by, I'd beam everybody up to space, and 5 minutes later, I'd beam them back down again, right? That'd be the best solution for that. So you really have to think about the business problem. And I think this is by far where most people mess up. And so I in my blog, I said, don't get caught in the sand trap. And I'm not much of a golfer, but if you golf, there's these things called sand traps. And if the ball gets in the sand trap, of a poorly formed business problem statement like the ones I have here, sure enough, you're going to do a lot of rework. You're going to come back. Your manager's not going to like it. You're not going to like it. It's just going to be a bad experience. What do I mean by that? Well, predicting employees that leave. Well, what do I mean by that? I just fired a bunch of guys. I have somebody else that went on maternity or paternity leave. Do you want me to predict those guys? So I want to, and do I have a field in the database that says, did you voluntarily leave, yes or no? You probably have a last day of employment, right? And then you have a reason why. So I need to derive those into a yes, no value. Did they voluntarily leave? Yes, or they didn't voluntarily leave. Now you may want to have other levels of that, but that's basically what you have to do. Now, if they leave, and I can predict when they're going to, I predict that they left. If it's like predicting an earthquake, I don't want to predict an earthquake is happening like now. I want to say there's an early warning, there's a window of time. So if I want to predict who's likely going to leave, I need to think about, well, if I want a 3-month window before they leave, I want to think, well, what did they look like 3 months before they actually left? So all the people that left, Did they recently have a move? Did they recently get a performance review? Did they recently not get some bonuses that they thought they were going to get? What were the reasons they left? What do they look like 3 months beforehand? So that's a much more carefully and well-defined business problem. And then it kind of falls into, okay, that would fall into classification. Predicting my best customers, that's a very loosely defined statement. What do you mean by my best customers? Do I mean maybe anybody that spent more than $500 in the most recent 18 months? Do I mean that, does it matter if somebody walked in and spent $600 3 months ago, or do I care about somebody that spent $30 a week for 20 weeks or whatever it is, and it adds up to that amount? Do I differentiate between those things? This is one that I did with Dunkin' Donuts, Dunkin' brands, like they're a public reference, so I can say that. They basically wanted to know, how can I make more money? But it boiled down to, they make a lot of profit off of selling iced coffee and drinks. And there's another sandwich kind of a shop that would say, if I can predict, I would sell these big gulps of sugary water. Well, maybe I want to give away free, what do you guys call chips, or potato chips, crisps or whatever, salty things. So maybe I want to say, well, with your soup, would you like some chips with that? Or with your sandwich, would you like some free potato chips? And then they probably say, you know what, I'd like a big glass of, soda water with that too, please. Could I have that? So you really need to think about the problem. And when you think about it, it helps a lot. So in week 1, we're going to be very specific about trying to have a very well-defined business problem statement. And I think in this case, we're trying to target customers who are good credit customers. But if it's just simply good credit, I could get a FICO score, right? Or an Experian FICO score. I could get a credit score like, oh, Charlie has 725 for a score. Well, it's not that simple. They have to have a good score, and they have to complete all their payments. So if they buy a refrigerator or a flat screen TV or a car or whatever, they buy it on a payment plan. Well, we want to know who bought it on a payment plan that had good credit, that actually completed all their payments. So that's a slightly different definition. And now when we do that, we notice, oh, only 20% of them are of that type. So also think about this. I could build a model that was 80% accurate if I always just simply predicted the left, right? Predicted they're not good credit. I'd get it right 100% of the time for these guys, but I'd get it wrong 100% of the time for these guys. So you have to think about how you set up the problem. There's more on that in a little bit. We're up to week 2. Week 2 says review the data. And there's another part of this. Don't just accept the data they give you. Think about what data you want to assemble. So more on that in a minute. But first of all, the data that once you do have it, does it make sense? Are all the values of age between 0 and 120? Or are they in minutes? Or are they in hours? Are they in year? What's the unit of measure? And do they make sense? Are the loan amounts reasonable? So look at the data, look at it in tabular, look at it in graphical form, and this is the notebooks. Look at graph the data, group it by good credit, bad credit. See if it makes sense. See if the data you have, holds water, or does it make any sense? If you're using the Oracle Data Miner user interface, you look at the histograms with a group by and say, there's more people who, yes, they buy insurance. Proportionally, it looks like they're all kind of the same, but maybe, well, these guys are all, okay, proportionally, it looks like the people that have a house, proportionally, it's like 30% of them here, it's like 15% there, and it's maybe 20% here. So you can kind of look at the percentage and see if you can infer some patterns, but that's kind of what you're doing in week 2. You're really having the discipline to look at the data for this very well-crafted business problem. On week, so like learning a new skill, playing the guitar, learning to ski, we're learning how to stop, we're learning how to take turns, we're learning how to play, a certain chord or a certain strumming pattern, whatever. Now we're up to week 3. We're going to focus a little bit more now on data preparation. And so I'm a lazy data scientist, and I hope you are too, because the other word for lazy is efficient. So I'm an efficient data scientist. So I go down to the guy that's got all the data, and I go, hey, I'm trying to build this predictive model to predict who's going to buy a Tesla, or who's going to leave Verizon or AT&T or Sprint or something. I need to know the person's age. Do you have age? And they'll say, I don't have age, but I have their date of birth. I could calculate that for you. And I'll say, great, could you do that? Because I need age. So the data professional is probably behind the scenes doing a lot of this work. Address, I don't really care at all what your address is. I want to know what's your distance to the destination. How far away are you from the store or the bank or whatever? I want to know better how long does it take for you to commute into the inner part of the city to work in the hospital district? Because if I'm looking for you, to find the best candidates, I need to think about things like that. Call detail records, I don't really care about who you call and all that, but I might want to interpret how many dropped calls have you had. So there's a lot of aspects of that as well. So that's a whole nother part here. That's really, really important. And I think this is where you do the engineered features. And the more you think of these things like, what's my percent of my salary compared to my peers? Well, that's a pretty good thing. But also, what was the change between last year and this year? So I have a customer I'm working with was trying to predict which employees were not, were voluntarily leaving. And we had a pre-built model and we were doing an okay job. And I said, well, what do you think of the right variables? And he said, well, people get assigned these jobs and they travel all around, and the rookies get signed to travel all over the place. They're in hotel rooms all the time and they burn out. And I go, oh, we don't have that variable or anything that captures that concept in the model. You need to somehow bring in another variable or two to capture that. So you really want to think about the data preparation in that. This other one, percent categories. So I have some customers that when you go to a hotel, they know how much you spend on the bar tab, the food tab, movies, all the different things that you might do at a hotel. They include all of that as well. And as you get more and more into this, the guy that was doing a presentation yesterday was talking about if you do a transaction at the same location with another person within 3 minutes, like I pay for my meal, they pay for their meal, and you do that more than n times, then you kind of associate, oh, they must be friends. So I can infer things like that. So I'm doing a certain amount of data preparation. I'm also going to do handling of missing values, outliers, and we're going to have default behavior for that. Notice we're going to recommend that certain variables be in or out. So this goes a little bit more. You can read the blogs and go into more detail. In week 3, we're doing data preparation. We're doing missing values, outliers, binning. These are things that we will do automatically for you using something called automatic data preparation. So you can override this if you want to, but we're going to do a lot of that for you. And so the data preparation, most of the work you want to do is thinking about what are the right variables, and then a lot of the other manual tasks like binning, outliers, binning, missing values, dealing with unstructured data or correlated variables. We have the algorithm's logic will try to handle that as best it can for you. So the hard part is getting the right data in there and having a well-defined business problem. We're up to week 4 out of 6. So week 4, we're going to say, let's start building some models. What I always recommend is the very first model you should build is an attribute importance model to find what are the key variables that are driving something. And I can do with that. So we're going to do that and find what are the key variables. Create model 2. It's just what I showed you before. Here are the key variables. Week 4, we're also starting to build and apply the models. And a lot of people say, well, how do I know that that's a good model? Well, I have a lot of historical data, and I don't mind on all the data. If I have 500 million records, I don't need 500 million records to build a model. I might take a sample of that, 10%, 20%, whatever, or all of it, doesn't matter, we can do it. But out of the part I build a model on, I might just take some of it, usually 60% of that data that I'm going to mine, and I have another holdout. I'm going to build the models using that, but I'm going to have a holdout sample, and I'm going to test the model against the holdout sample. So it's from the same data set over here, but I'm going to build a model on some of it. I'm going to kind of close my eyes and not look at the other data. I'm going to apply the model, and I'm going to look at the predictions and see how well the model works. That's what we do. That's what surprises a lot of people, like, oh, so that's what you do. That makes a lot of sense. And so what I always contend is machine learning is not that complicated once you kind of look under the hood and you see what's going on. It's very sort of logical and approachable. If you're using Oracle drag and drop Oracle Data Miner, you'll have a user interface like this that'll walk you through it. Very easy. If you use the notebooks, we have example notebooks. We're up to week 5. We're going to evaluate the model, gain, lift. You're basically looking for a high lift here. There's a lot. This could go on and on about how to evaluate the models, but in AutoML, we'll even automatically pick a good one for you. But you're basically kind of seeing what, and if they're all close, pick the model you like the best, or even take 5 or 10 models, make 5 or 10 predictions. We're up to week 6 where we're going to apply the model. Is just doing a SQL query where I apply the model, the N1 class model here. Now I get my predictions, my probabilities. There are very high probabilities here, but that's the top of the results there. and I could just automate this whole thing as a script. Okay, this is a fraud detection model here. And so that's kind of it. If you want to try this on your own, as I said in the last time, there's a lot of tutorials, there's a lot of hands-on labs, various different resources, YouTubes that are out there. And the hope is that, this I talked about before, the hope is that you'll evolve to, call yourself an Oracle data scientist. We are working on a certification process for this, but it gets, I think it's a very approachable, very logical journey. With that, I will end and say thank you.